fast. This is a different kind. They call a fuel cell a battery. It is, to my mind, not really a battery because they are constantly pumping in the reactants. Let's concentrate on the hydrogen fuel cell. Please know that a fuel cell means that chemical energy of a fuel is converted directly into electricity without burning the fuel. So that's where it gets its association with batteries. It has the same definition as a battery. But now we're talking about fuels as opposed to just reactants. Okay, so overall the reaction is so exciting because it's hydrogen plus oxygen. So we have hydrogen plus oxygen producing water. And the iconic look of these batteries, these fuel cells, is water dripping out of the exhaust, as opposed to all sorts of gaseous species. Okay. Alrighty, well, oxygen's pretty cheap. It's easy to obtain from the atmosphere, but this is our big limitation, hydrogen. And notice that's elemental hydrogen. That is not in a compound. We got plenty of water around. In fact, remember, hydrogen atoms are the most plentiful in the earth. And it's season, but it's H2 that we need to utilize. And we introduce hydrogens at the top. In the middle, we have a catalyst reaction, a cathode reaction, an anode reaction, and it is a redox reaction. It becomes a redox because while these are both neutral, hydrogen and oxygen, over here in water, even though this is not an ionic compound, we can say that water has a partial charge, negative charge, and hydrogen has a partial positive charge. So they've lost control of parts of electrons, so this does comply with the definition of a redox. Here's the chemical change, and in the anode, the hydrogen becomes H+, produces 2 electrons. The cathode, the oxygen, becomes 2-, and overall, we take those out, and it becomes H2O2 and H2O. You know, please don't spend too much time on this because the cathode reaction especially is more complicated than we really want to talk about in this class. So I would like you just to appreciate the fact that this does go under the largesse of a redox reaction, but the net equation is hydrogen comes together with oxygen gas and makes water. Now you're going to say, what are the advantages? Why don't we just use these all over the place? Well, the pros: water is the only product of the combustion. Remember, combustion is the reaction of a fuel with oxygen. So hydrogen's our fuel, oxygen's our combustor, and water is our product. Versus a hydrocarbon where we've got CO2 and water, plus oftentimes other products. The fuel value of H2 is huge, which means gram per gram it puts out a lot more energy than any fossil fuel. Hydrogen is the most abundant element. We talked about that. Golly, but cons are very much engineering feats that need to be overcome. So, for example, there's very little natural elemental hydrogen. It's hard to store. The boiling point of H2 is negative 400 degrees Fahrenheit. Think about trying to put that under pressure enough so it's liquid, so you have enough in there to drive to grandma's house and it's sitting right underneath your butt. It's one thing to have gasoline, which is of course a flammable liquid, but it's kind of scary to have a very flammable chemical in your car that also is under very high pressures. It also is so small that it migrates through metal, so you can't just put it into a metal container. You've got to put it through into a special, very tightly knit solid. I'd like you to know these pros and cons for the exam. they're working very hard on West Campus to come up with the solutions to all these. Both fuel, that's the H2 oxidizer, O2, must constantly flow in there to continue the chemical reaction. And the future of water as fuel, this is a separate thing, but the cons, another con here, or positive pro, I don't know, but you can find species that fall apart to produce H2 around the world. And that's another place where people are doing research. They're called hydrides, metal hydrides and such. And that is a place that, but those aren't cheap, you see. One of the biggest advantages, remember, is relatively, because the infrastructure is so there, but oil is gas, natural gas, and coal are still much cheaper. How about water as a fuel? Wouldn't that be fun? I mean, leaves do it all the time. So why don't we figure out a way to split water, H2O, into H2 and O2 using a catalyst? And they have done this for many years in research labs, but the catalysts have been so stinking expensive or kind of toxic. But there's a guy at MIT called Don Nacera. His leaf catalyst is pretty cool. And just to remind you, plants split water all the time in photosynthesis. He would like to take H2O and split it using, and I won't go into the catalyst at all, but it's pretty inexpensive. It's really bad, its efficiency. But the point is, he says he doesn't care. Forget about efficiency. Go for cheap, 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 and very durable. So the Indian government especially is giving him huge sums of money to come up with these, because what would happen is you'd have a little bed in your basement, and you would keep producing H2 and O2, react them in a fuel cell, and make water again, and it would be a big cyclical energy source. And wouldn't that be outstanding?